Hello everyone, welcome to my video. Let me introduce myself. My name is Najwa. I am 22 years old and a student from UTHM. In this video, I will talk about waterproof characteristics on irradiated packaging material. Among all types of packaging material, plastic was one of the mainly used in the list. Unlike cardboard, metal, and glass, plastics are flexible, lightweight, odorless, great in mechanical strength, hygienic, and most important thing is low cost. Seems that most people have an obsession with plastic. The beloved planet become very dirty and unorganized as the plastic covered it since we use plastic for more than half a century. Polyethylene, polypropylene, polyester, and substitute olefins are some categories under plastics. There are more variations of polymers invented under them, such as polyethylene can be divided into three more groups: low-density polyethylene, high-density polyethylene, and linear low-density polyethylene. With all this variety, almost 40% from plastic production used in packaging sector, which is not worth it as it used only for a moment, but the lifetime of plastic is more than a century. Packaging material used a lot in markets, industries, and households. Packaging waste reported over 67 million tons, leading to serious complication towards environment. Nowadays, bioplastic has been well known among society as awareness keeps updated from time to time. Therefore, biodegradable things always become the first selection, as bioplastic known for its environmentally friendly and easy to dispose of due to its natural chain of polymer. In detail, bioplastic is a polymer that is based with biodegradable sources such as carbohydrate or fat and oil base. Starch got an attention for accessible major feedstock. Amylose and amylopectin ratio is the key to achieve common plastic characteristic. Corn, wheat, and potato mainly got attention due to major accessible feedstock. For example, 62.8 million tons of potato produced at the same time, 782 million tons of rice production, and about 147 million tons of corn in 2018. Amylopectin is the major component present in starch, as a crystalline region with range ratio is 75 to 85%. While amylose is the opposite present in starch, as amorphous region with range ratio is 20 to 25%. Ability to attract water molecules is needed to pay attention to achieve waterproof or at least near to the hydrophobicity level, but even so, biodegradability needs to be maintained. Therefore, waterability depends on water solubility of the bioplastic. In detail, moisture content percentage will be studied in change of bioplastic weight before and after dried up in the oven. Fortunately, adding with other plasticizer will affect relative humidity, where water content of material will follow it. The lower the RH, the lower the water content will be when amount of plasticizer increase and vice versa. Therefore, contact angle measurement will be needed to measure hydrophobicity. Sessile droplet mostly used for examining waterability. Angle of 0 degree labeled as most hydrophilic and 180 degree for superhydrophobic for showing level hydrophobicity of the surface that able to resist the water attraction. When it comes to industrial use, gamma radiation and electron beams are generally involved. The reason for gamma radiation is because gamma rays are extreme in penetration and cobalt-60 mainly used and often for sterilization purpose. Unlike gamma radiation, electron beams have limitation for penetration. When radiation is exposed to high polymer, different reactions may occur. There are four: abstraction, recombination, disproportionation, and polymerization. The effect of radiation leads to cross-linking or degradation towards chemicals. In Title 21 of the Code of Federal Regulation, CFR, few packaging materials were listed irradiated in Regulations 179.45D with maximum dose 60 kg. This shows that packaging material was already introduced with radiation for years. There will be four different procedures for making bioplastic: pure starch with sorbitol, pure starch with citric acid, mixed starch with sorbitol, and lastly, mixed starch with citric acid. For mixed starches, there will be combinations of corn potato, corn rice, and potato rice starches, which is inspired by Mary Chelvam's study. Those bioplastic samples will be compared with polyethylene, polypropylene, and polylactic acid. To test hydrophobicity, water contact angle analysis, the test will use sessile droplet to see interaction with polymer molecules. Next, content of moisture will be done by weighing difference of weight before and after dry. Soil burial method will use for consideration of landfill condition for biodegradability tests. Other than that, those samples will undergo tensile strength tests, scanning electron microscope, Fourier transform infrared spectroscopy. For irradiation treatment, dose exposure will be 10 kg, 25 kg, and 50 kg. For the wettability, pure starch might have higher possibility with water contact angle lesser than mixed starch. Not to forget, moisture content might higher for pure starch than mixed starch. Even for tensile strength, mixed starch can have better result but cannot defeat with petroleum-based plastics. Sorbitol might perform better than citric acid as plasticizers. Compared to petroleum-based plastic, bioplastics have better biodegradability and polylactic acid as well, but might need more time. With certain dose, during irradiation treatment exposed to the samples, which is 10 kg, 25 kg, and 50 kg, bioplastic samples might have improvement for tensile strength aspect, but some of them can experience degradation as solubility have chance increase. Finally guys, thank you so much for hearing my project, and this is the end of the video.